Welcome to IIT Foundation Series of Class 9. In today's class, we will be solving a few problem sums based on polynomials. In the first sum, we need to find the relationship between A, B and C, and we have been given an equation of x where we can see on the left side we have a polynomial of degree 4 and we have square root of that, and on the right side we have a quadratic polynomial. So from this given relationship, we need to build a relationship between the coefficients a, b and c. So what we will do first is we will square both the sides of this given relationship, and by squaring what we will get is, here on the right side we will apply this identity. So here it will be ax square then whole square plus bx then square and then c square plus 2ab means 2. Here a is ax square and b is bx plus 2bc, so 2 then b means bx, c means c here, and then 2c and a means ax square. So by simplifying we get finally, so what we can see here is on both the sides of this equation we have biquadratic polynomials where we have x here and highest power is 4, and here also we have a polynomial of x and highest power is 4. So what we can do is we can equate the coefficient of each like term, and if we do that, then if we start from here we have x to the power 4 and here again we have x to the power 4. So if we equate the coefficient, then it will be a square is equal to 4. So from there we can say that a will be equal to 2. Now if we equate the coefficient of this constant coefficient, here we have c square and on the left side we have 16. So easily we can say that c square will be equal to 16. So we can say c will be equal to 4. So far we have obtained the value of a and c. Now what we need to do is we need to find the value of b. So far we have obtained the value of a and c. Now what we need to do is we need to find the value of b, and for that we can choose b square x square this term, and we have another x square term 2ca, and from the left side we have x square term, here only one x square term, and then coefficient is 25. So we can equate the coefficient. So from the right side it will be b square and here we have 2ca, so plus 2ca, and that will be equal to 25. Now we know the value of c and a, so it will be value of c is 4 and value of a is 2, and that will be equal to 25. So we can say that b square will be 25 and it will be 8 16. So 25 minus 16 and that will be 9. So we can say the value of b will be 3. So what are the values we have obtained? So from these three values, one of the relationship that we can build between these coefficients a, b and c is, we know that 2 plus 4 that is equal to 2 multiplied by 3, that means 6. So 2 means a, 4 means c, and here it will be 2 multiplied by b. So this is the relationship, or we can write that b is equal to a plus c by 2. Now the next question, where we need to find the square root of the algebraic expression which is the average of the following expressions. So what is the average value? The given polynomials or expressions are x square plus 1 by x square. Then we have minus 2x minus 1 by x, and then we have minus 1. And since we have 3, so when we'll find the average, we will divide by 3. Since here we have x minus 1 by x, so we will use this identity. Otherwise, we know that this can be equal to a plus b whole square minus 2ab as well. So the first term, x square plus 1 by x square, this expression can be written as, in this as per this identity, it will be x minus 1 by x then whole square then plus 2ab. So 2x and 1 by x, and we have minus 2x minus 1 by x, and then we have minus 1 and then whole divided by 3. So this can be further written as and then it can be written as, it is in this form, a square minus 2ab plus b square. So where the a itself is x minus 1 by x, and this will be minus 2a, and b means here we can write 1, and b square means it will be 1 square. So we will be using this identity a minus b whole square. So it will be x minus 1 by x, which is a here, and then minus b means minus 1, and then whole square, and divided by 3. And from the given problem statement, we need to find the square root value from that average. So square root value will be, it is now clear to you what the value will be. It will be x minus 1 by x minus 1, and then divided by root over 3. Now the next problem sum, where we have three algebraic expressions and each of the algebraic expressions are perfect square. Then we need to find the value of L plus M divided by N. We know that if we have this type of quadratic polynomial, then from Siddhacharya equation or from Siddhacharya formula, we know that the roots of this quadratic equation or polynomials will be, now if this ax square plus bx plus c, this quadratic polynomial, is a perfect square, then we know this b square root over b square minus 4ac, that value will be equal to 0. And in that case, the value of x, that will be only minus b by 2a. And this concept we will be applying in the given polynomials. So the first algebraic expression or polynomial is Lx square plus mx plus n. So if it is a perfect square, then as per Siddhacharya formula, the value of x or the root will be minus b by 2a. So here b means f, the coefficient of x. So it will be minus m divided by 2a. A is what? The coefficient of x square. So it will be minus m by 2l. From the first equation, what relationship we are getting? X is equal to minus m by 2l. So from here we can say that m will be equal to minus 2lx, right? So in the second equation, where we have x is equal to minus n by 2m, here if we put the value of m, what we have obtained in the previous step, then it will be minus n divided by 2, and the value of m here, it is minus 2lx. So it will be, finally minus minus will cancel each other, so it will be n divided by 4lx. So from here we can again say that n will be then equal to 4lx square. Now in the third equation or third relationship, we have x is equal to minus l by 2n. And what is the relationship between n and l? N is equal to 4lx square. So we can put here, so minus l divided by 2, here it will be 4lx square. So l will cancel each other, and here we are getting minus 1 divided by 8x square, and that is equal to x. So can't we say that x cube will be equal to minus 1 by 8, and minus 1 by 8 means that can be represented as minus 1 by 2 and then whole cube. So from here we can say then x will be equal to minus 1 by 2. So from the first equation, x is equal to minus m by 2l. If we put that value of x here that we have obtained in the previous step, then it will be minus half will be equal to minus m by 2l. So minus minus will cancel each other, 2 will cancel each other. So from here we can say m will be equal to l. And now in the second equation, we have x is equal to minus n by 2m. So from the second equation, again x is equal to minus n by 2m. So again if we put the value of x, which we have obtained as minus half, then minus half will be equal to minus n by 2m. So again minus minus and 2 will cancel each other, and from here the relationship between n and m that we are getting is n is equal to m. So we can say that m is equal to n is equal to l. So the values of all these coefficients n and l are same, and what we need to find was l plus m by n. So l plus m by n, so it is 2n by n or it is 2. Now in the next sum we have been given a polynomial of x where the highest degree is 6, and if that polynomial, that algebraic expression will be a perfect square, then what value we need to add to that expression. So here we will be applying the long division method of finding square root, and then we will see if there is any remainder. If it is, then how much is the value. So here the first term is x to the power 6. So the maximum value that we can take here is, or the only value that we can take here is x cube. So when x cube will be multiplied by x cube, that will give us x to the power 6. So here we will be writing x to the x cube. So this value will be x to the power 6, and then we know what we do, we will subtract. So this x to the power 6 and minus x to the power 6 will cancel each other, and the rest of the terms in that given polynomial now we will consider. Now we will take the double value of this term, which is finally going to be the square root value of this given polynomial. So if we take the double value, then it will be 2x cube. Now 2x cube, and here we have the highest power of x, that is 4. So what we need to do is we need to multiply by x, then x cube, when it will be multiplied by x, that will give us x to the power 4. And coefficient value, if we see, here we have 2, here we have minus 6. That means coefficient wise it should be multiplied by minus 3. That means we will multiply by minus 3x. So first we will write minus 3x here, and then we will be multiplying by another minus 3x, this given this algebraic expression, and that is the rule. So we are performing this multiplication separately. So 2x cube minus 3x, and again we will be multiplying by same term minus 3x that we have added here. So that will give us here minus 6 x to the power 4, and here it will be plus 9x square. So that value we will be writing here minus x to the power 4, and then we have 9x square. So here it will be, now again we will subtract. So it will be plus, it will be minus. So this will cancel each other, minus 6x to the power and plus 6x to the power 4. And from here what will remain is 4x cube. Then here 8x square minus 9x square. So it will be minus x square, then minus 10x, and then plus 3. So what we will do next is, what value here we have, okay, here we have missed this minus 3x, we should have written here. So now we have in this square root value, now till now we have x cube minus 3x. So now we will take the double value of those terms. So it will be here 2x cube minus 6x. So if we multiply by 2, then it will be this value. Now we will see the highest power of x of the polynomial or algebraic expression that we have in this stage, and that is x cube. And here also we have x cube, so we don't need to multiply this expression by any x term. But here the coefficient of x cube is 2, and here the coefficient of x cube is 4. So we will multiply by only 2. So, and that is plus 2, because here it is plus, here it is also plus. So that plus 2 we will add here, and then by the same term we will be multiplying that expression. So 2x cube minus 6x, and we are supposed to multiply by 2. So that 2 we have added first, and then we will be multiplying by the same value. So it will be 4x cube, and then we will have 12x, and then we will have plus 4. Now if we subtract, then it will be minus, it will be plus, it will be minus. So these two will cancel each other. Then what value we will have here is x minus x square. Then from here it will be plus 2x, and then from here it will be minus 1. So minus x square plus 2x minus 1, this is the remainder value. That means if we take minus 1 common, then it will be x square minus 2x plus 1. That means this is minus, and this is the identity x a minus b whole square, so it will be x minus 1 whole square. So this much was the remainder that could not be vanished. But if given expression, algebraic expression or polynomial, if we want that to be a perfect square, then we know by long division method finally the remainder value should be 0. And now if we want to make this remainder value 0, then what we have to do, suppose if we have the remainder minus 5, we know that if we add plus 5 to that, then that value will be 0. Similarly, we have remainder minus x minus 1 whole square. So to that, if we add plus x minus 1 whole square, then they will cancel each other, and then final remainder value will be 0. So as per the question, what needs to be added to make that given polynomial or algebraic expression a perfect square? So our final value that we need to add to that given algebraic expression is x minus 1 whole square or plus x minus 1 whole square. So this is how we need to simplify this type of problem sum. Now the next one, and in the next problem sum, we have the concept of summation, and we have this sigma symbol. So what we will do here is, first we will expand this series sum. So here we have this summation, and this summation, basically this is a series sum of the variables x, y and z, and that is represented by only this variable x, but in place of x we will be putting separately x, y and then z, and there will be a summation between all those variables. And then we have cube value, and that cube is the whole cube of this summation or series sum. So if we expand this series sum, then it will be, first in place of x, the first variable will be putting, and that itself is x. Now because of this sigma sign, we will be writing or we'll be doing summation, and then next variable is what? Y. And then of that whole summation we have this cube, so it will be x plus y plus z and then whole cube. And then minus, again we have series sum, but this time the term itself is the cube value of some variable, means here it is represented by x cube. So when we will expand this series sum, it will be basically x cube for the first variable, which is x here, and then we will have this summation, and then for the next variables, and that will be y cube, and then for the next variable, so that will be z cube. Now we will apply the relevant identities. So now it is x plus y plus z whole cube. So x plus y can be taken or considered as a single term, first term, and this is z as second term. So it will resemble this identity a plus b whole cube. So we can write a cube means x plus y then whole cube, then plus b cube means z cube, and then plus 3ab. So 3a means x plus y and b means z, and then we will have a plus b, so x plus y plus z again, and then we have, and now again on this first term, if we apply the same identity, then it will be again x cube plus y cube and then plus 3ab, so 3xy and then x plus y, and then we will have, so plus x cube and minus x cube will cancel each other, plus y cube minus y cube and plus z cube minus z cube will cancel each other. And now the second term, if we factorize further, then we will be getting, so finally it will be 3 multiplied by x plus y, and from here y plus z is the common, so y plus z will be another term, and then it will be multiplied by x plus z. So this is the final answer. So I hope this class was helpful for you. With that hope, I end today's class. Thank you.